Welcome everybody to the Tech Talk. Today agenda is that we start with a small overview, more from an architecture point of view, identifying the gaps, the problem many companies might have today, and talk about how to solve that from an architecture point of view with the configuration platform. And then we will run through a small example. We will build up or we'll tell a little bit about using a knowledge graph to represent the variability of a product, importing these data into our configuration platform, Configit Ace, enriching the data with additional rules and logic, and then using the compiled solution space to get some insights, feedback into the engineering and design process, and also closing it up by releasing it to sales so that sales can sell the product and create orders on that. We'll summarize it, and at the end, if you have some time, we can have a small question answer session. So I will start with the overview. As many of you maybe know, our CLM circle here, I have colored the engineering area in red. So all the red items mostly belong to the engineering area, the blue one to the sales area, the yellow, orange one to the manufacturing area, and the green one relates to the modeling part, the configuration platform. We skip today a little bit the service area, so there's not much relation directly between the model-based system engineering and service, but at the end I also have a few benefits for services when we get this process streamlined. So the challenge today, starting typically a product design in the model-based system engineering tool. Hopefully you already do that in a very collaborative way with people from other departments, building up the initial design. And once you have the initial design defined, these information typically flow into the engineering, the PLM and RLM world to build up the mechanical, electronical, and software world for your product. On the other side, we have sales and the different sales channels like CPQ, webshop, websites, partner portals, where customer can engage with your sales team or in self-service with the configuration. These products can be configured and sold, and as an order entry moved into the ERP system for manufacturing. As we can see in the middle, there's a little bit space, and that's the area we will talk today about, and that's the area in between engineering and sales. And very often there are clever modular teams who collecting all the information relevant for the configuration and bring that together into the sales channel, sales configuration tools. Sometimes there are maybe exports of data, Excel sheets, which will be imported or manually entered into the configuration engine. There are a lot of information which kind of get from the heads of the people into the configuration engine. So it's often a very immature manual task here. And that leads, unfortunately, to some issues, and you might recognize some of them. There could be a delay in the release cycle. So whenever engineering has created something new, a new feature or a new product, it takes a bit longer to get these into the sales channels to sell the product or new features. And in worst case, you might also recognize some invalid configurations at the end in manufacturing, as maybe these manual processes also lead to some failures, and there might be some wrong configurations still in the configurator. And some root causes of that could be, for example, that you have a missing suitable representation of your variability of your product model. So whatever model-based system engineering tool you use above here, it might be that it lacks on information about what are the variability of your product. There could be a lack of integrations, as we see here in this manual flow, that there are many data manually moved from one system to the next one. Or it could be also that you have more a sales-oriented configuration engine, which is maybe not tailored to import data from engineering into the configuration engine. And these are kind of the areas we will talked about today. So let's look into how that could look like with the configuration platform in between. And the first step we can do is we can import information from the model-based system engineering. That requires, of course, that the variability of your product, the features, functions, and the constraints are somehow recorded in the model-based system engineering. If you use a variant management tool, you might have this information and they can be imported. I will today use a knowledge graph for this representation, but similar integration can be done with any other tool as well. So we will take over this information into Ace model. We'll build up a first kind of skeleton model based on the information from the MBSE tool. And we can verify and test that and enrich it, of course, by the different users in a very collaborative way. If possible, we can feedback information created in Ace, for example, added a rule or something like that, more characteristics into the model-based system engineering tool, as long as this tool also offers kind of bidirectional exchange, importing and exporting data. We typically synchronize with the PLM and RLM world because the RLM typically defines what features and functions in the software is available, what are the hardware requirements underneath, and requirements to sensors and all these things. And on the PLM side, we have, of course, the bill of material and other information which has to be aligned with the configuration. So there's typically a link between both worlds. And then we will release this information into the configuration platform, Configit Ace Configure, which is kind of the runtime environment where now the different configurator can access the configuration from a single source of truth. It gives us a smooth integration from the first idea on top, flowing the data into the configuration engine, and they will be just enriched on this journey. So it's no double maintenance so that you have to enter data again and again. It's just taking the data from the system before, enriching it step by step until you get to the final state. But there are also additional capabilities here. While you're doing the engineering, there can be kind of some loops. And while you're building up your product knowledge, there can be also some insights you might like to feedback into the initial design or into the implementation in the engineering area. And I will have an example for that later on. So that's a little bit the overview we will kind of go through today. From the idea on top with the knowledge graph, importing the data, enriching it, make it available, get some insights, and release it into sales. Another nice example of a configuration platform is that you become very independent from the other surrounding systems. So today, many of our, not our customers, but only of the companies I see in the market is that they want to move to a new solution. Might it be a CPQ solution, a PLM solution, or ERP solution, but they also are forced to migrate the product knowledge they have in the systems. And with the configuration platform, you become more agnostic. So whenever a system around changes, and I have visualized it here by changing the color of the specific systems, the configuration engine can stay constant. So you don't need to change anymore the configuration knowledge, the product model, when you exchange a PLM system, a CPQ, a web shop, or whatever holds today your configuration knowledge. That's a nice benefit for the future, to be more agile, to exchange systems while you're going. So let's look into the example. And in this example, we design a car. Every one of us knows how a car looks like, so that makes it quite simple to follow that. But it would be kind of the same process if you build a component like an engine or a machine or a complex plant. The story might be quite similar here. And all typically starts with someone having an idea, might be a product manager, C-level, decides to create a new sports car in this case. So we have an initial design already. And as we do not develop the first car here, we already know there are certain components we have in such a car. And we also can recognize some initial design constraints. As it is a sports car, we know it has just 2 seats, typically the engine at the back. Have a specific body type, sizes are recognizable. So there are some constraints already we can get from the design. And when it comes to other components, it might be that you have to design something for a specific market segment, for a new technology or something like that. So this information should be now recorded somewhere. And that looks a bit wrong. Sorry for that. And I will use the knowledge graph here for represent this information. So a knowledge graph, for those of you who never heard about that, is kind of a lot of dots with lines in between, simple spoken. The dots are nodes or vertex in the graph, and they're representing objects in your product model. So that could be a characteristic, a component, a rule, a specification document, a default, whatever is related to the variability of your product. And an edge, that's the lines in between the dots representing connections. And the connection could be, for example, all the characteristics used in a specific rule. So then this rule has connections, lines to the specific characteristics it uses. And that way you build up a large graph view of your product model. And we see that in a moment a bit more in detail. So it's quite similar to a social graph where you have as the nodes some people and the lines representing if you follow them or if you are friendship with them or something like that. So that's quite similar representation here. So why a knowledge graph? Sorry that the animation does not work. The knowledge graph is, in my point of view, a very natural representation of these, as you have the different objects, the characteristics, which have some dependencies in between. It is quite easy to represent the different aspects of your product model. If it is mechanical, electronical, software, sales, you can all that bring into one view. It's a well-known technology and widely used, as mentioned in social networks, for example. It's kind of the same representation. So that means there are available tools, algorithm, analytics, AI capabilities to work with these graphs. It's ongoing research, so it's not a dead technology. And what is very important also, it has some standard formats. I will use today GraphML to read the data, but it could be also written that way. So that's really important. If you have a model-based system engineering tool, it requires some kind of export capability, or it is an API where we can access the data and import this information into the configuration platform. So first I will start with a kind of general car model. So we get now the information, we have to develop a new product, we get together a group of people, and we start the engineering or the design phase for it. And in the first step, we just record all the characteristics our product has, defining what are the dependencies in between, and maybe already define what are the modules or modularity of it. And I have created here a small example. So for the car, it is different components here. They are colored in the different colors here. So we have the wheel, we have the drivetrain, the platform, the interior, software functionalities like navigation systems, sensors, exterior, so some aspects of the car. And all these dots representing characteristics or components of our product. And the line in between is just defining that certain characteristics depend on other characteristics. So for example, we have here in the top the rim size, and the rim size has somehow a dependency to the disc brake size. Means as large as the disc brake is, as large as the rim has to be, or yeah, if I have a small rim, then I only can have a small brake. So that's the way how they restrict each other. And the same way, we have the motor down here, which defines what brake system you need, defines a certain size of the disc brakes and a certain size of the wheels, and so on. So there's also some chains of dependencies then in such a model. And it's quite simple to write these, draw these lines in between, as it is quite natural that certain characteristics depend on other characteristics. In the next step, I've used the same graph and added rules to it. So the coloring has now changed. The coloring is now by type. So the red dots are defaults. The blue one are rules. The violet one are characteristics. The green one components, and the yellow one are specifications. And I now bring in here a couple of information. So I have one rule for the tire, for example, defining which tire has which dimensions. One rule for the rim, defining which rim has which dimensions. And by the dimensions, it defines automatically what are the allowed numbers of combinations between these both. We have some specifications from the product manager defining which rim designs will be added to the product. Theoretically, we can add hundreds and thousands of different rim designs, but typically in a configurator, you have around 5 or 10 different designs. We have some company definitions, which are the vendor list for tires, for example, and the default, what is a preferred vendor. So just to give you some examples of the different objects, but we also have some specifications in between here, which brings the connection between the rim mounting and the axis, where we have a company specification that we're using 5 screws, not 4, not 6, we're using here 5. And also down here, we have a specification for the exhaust system, so a regulation in the different countries. Yeah, so that way we can build up the product model. And if you bring in, again, the red lines to the same view, we also can directly see that we have some of these just reached by the red lines. So that means there are some missing rules. So I easily can see how far I got so far and where I have some missing areas where I need to add some more rules that all these elements are somehow covered by the rules I have to define. So that way I can easily build up it in a graph view, step by step, my product model. I can collaborate on that. I can, of course, cut out graphs or move them around as I want. And as we have a graph representation, we already can use some software tools, algorithm, to get some insights. I just used here a few of them. So we have, for example, minimal spawning tree, modularization, auto layouting, filters, up to dynamic things like artificial intelligence, suggesting nodes, which are missing, similar to, hey, you know this person, you maybe also know this person in a social network. It could be also done here. Hey, you have in other products these restriction, you maybe need also this restriction in the new development. So we can see here different layouts, a circular, bit more tree-like view. Here colored by the modules, down here colored by the centrality of the element. You can see it here more, as darker it is, as more central the element is, as more restrictions or more influence it has, as more lighter it is, as more outside it is, less restrictions it has. Also, the lines are here colored by the minimal spawning tree. All the red lines are on the minimal spawning tree. The green lines are outside of that one. So that way you can use different of these algorithms to get some insights into your product model. It depends heavily on how the structure of your model is and so on, which of them gives you some insights and benefits. So next step is importing. So we have now defined all our knowledge in this graph or in a different tool, and we now want to get this information into the configuration platform. So behind the scene of these dots, there is a table with some meta information. So you can see some of them already in the dots, but also some type definitions and so on, you can add here behind the scene as meta information for each of these dots. Yeah, and this can be also done, as earlier mentioned, with any other model-based system engineering tool, variant management tool. The important part is really that you can export the data from these tools, or it offers an API to access the data. Then we can take over the information, the variability information, characteristic definitions, and so on, and import that into our configuration platform. And from here, the flow will be the same. We have to convert the data from whatever format we get into our internal product model structure, get these data imported into Ace, and then you can enrich the rules and so on even more. So if you get a more kind of technical representation of your product model imported, you can enrich it with more sales-specific views and so on. Some examples of the results after an import. We have the characteristic definitions over here, the different modules with the different data types. We have the rules imported as a placeholder, also aligned to the different modules. This is, for example, a table rule, which currently allows any combination. And that's, of course, something which needs to be filled out. If you already have databases with this information available, they could be also imported directly so that you can take over the data from the database you already have. And the view definition, so all the domain sales elements are imported into a sales view so that you get for the different modules sales relevant characteristics imported, and the technical characteristics stay a little bit outside of the front end. They are in behind working, but not shown to the user. So the next step is collaboration. So you now build up your product know-how, build up the rules and the information from the various perspectives, the engineering view, the sales view, maybe manufacturing view, service view, whatever is relevant for the product model. And you now can also get some insights based on that. And I picked out here one component. It's the center console. And let's imagine we are a developer or an engineer. We have now to develop the center console part. So that's a part between the front driver's seat and co-driver's seat, the middle console, where you have typically shifting and handbrake and so on. Based on the graph, we already can see what are the characteristics kind of influencing, defining the variability of this part. We have also a rule down here restricting a little bit the combinations. So all that goes now into our configuration engine and RBT technology, virtual tabulation. And you can now receive the information about how many variants are allowed in your product model. And for this example, it's 32 different variants based on the box size, the shifting type, the electronic parking brake, yes or no, or the color. That also means 32 spare parts for service or for your stock to keep. But what happens if you are not aligned and working collaborative on your product model is that sales could add some bundles to it. Very typical thing, sales creates a bundle and defines, hey, auto shifting can be only combined or only sold together with electronic parking brake. So you can't get the one or the other separate. You have to take them together. So it's a bundle. Looks good from a sales perspective, makes it simpler to offer. But it creates a situation that you now only can sell 24 variants. So that means you have 8 variants in worst case over-engineered. And that's the reason why you very early should get the sales view and perspective into the product model so that you can take these into consideration, what variability you really need to develop. Not everything what is technically possible might be later on also sold in the market. And that is, of course, a problem if engineering and sales is not aligned on what is built and sold. So it means you can really heavily reduce your over-engineering and save, in this example, for one part, 8 variants on the stock. And if you create that for the whole product model, there might be even more. So that's just money, time, and capacity you're wasting here. So that's really important, collaborative working on the product model. Yeah, now we're kind of the end of the story. We're releasing our product model into sales. So after we did a couple of loops in engineering, improving our design, we want to release these now as a product we want to sell. Sales can offer that in the own tool, CPQ, or it can be offered on web shops and websites in a self-service way, and the order can go into manufacturing. And if you are very early aligned and the product model is built up very early with all the perspectives, you also can start earlier selling. So when you have a very sequential process, first engineering done, then you build up the product model, you're also losing a lot of time to get your new capabilities to the market. And the same channel can be then also used if you get market feedbacks, if you improve your product over the time, these information can flow into the same channel again and takes the same path so that you also new functionalities and updates get faster to the market. And I have picked out here some of our customer voices from different customer slides we have. And they are talking a bit about getting 0 errors at the end, having faster time to market, less effort in maintaining the stuff, having the configuration for multiple configurator front ends, reducing the delivery time, and so on. So there are a lot of benefits you get if you have really a streamlined process from the idea initially into the configuration engine, building up your knowledge and getting that into sales with less manual work in between. So summarized all of that means we have now started from the idea over engineering, sales, and manufacturing. So for engineering, main benefits are that you avoid over-engineering, that you can use the insights to improve your design and what you want to engineer. For sales, the benefit is that you get a faster go-to-market and helps you to be ahead of your competition. That's very important. As earlier you get it out in the market, you maybe get with the new features and functions earlier on the market as your competition. Your modeling benefits, so collaborative modeling, smooth integrations, which helps you to build up your product model more efficient. For manufacturing, more error-free configurations and a faster order to production process, so that the data really flow digital into manufacturing without any problems. And as mentioned, one for the service area, we have less unrequired spare parts on stock. If we avoid over-engineering, we also avoid that we have parts in our stock which can be never sold. So that's a little bit the tech talk we have prepared for today. If there are any questions, if you have questions afterward or you're looking at the recording, you can send it also by mail. And if you want to see somewhere more a deep dive, some more information to certain topics, just let us know in the chat or by mail. Then we can also plan some follow-ups on that.
Thanks a lot,
That's from my
Heiko.
side. Yeah.
Thanks a lot for the technical remarks, and thank you for a very insightful presentation on the model-based system engineering capability. Now it interrelates with ACE. So I have received a couple of questions. We're about to close the session already, but I think we can take one or two, and then we can respond to other questions per mail.
Yeah,
so there's a question coming in asking, can the integration between MBSE tool and Configit product model also be bi-directional?
Yes, of course. It requires, of course, on the model-based system engineering tool that there is an API available to import the data again. But if that is the case, we have export and import capability, then we can exchange data in both directions.
All right, thank you for this answer, giving the insight. And then I think we take one more question before we close down. I can see that this question was asked on slide 18. So it says you talked about the additional sales rules. What happens if sales add such rules after a year or so after the release?
Yeah, of course, that was now to avoid it during the design phase. But if these kind of sales bundles will be added later on, it kind of has the same impact. It blocks some variants. But we also have functionalities to find these things. So we call it a blocked value. So once certain selections in the configuration is no longer available, the configuration engine or the compiler finds these elements and lists them as blocked values, so that you directly get feedback that certain elements are no longer available, and you can decide if you want to phase it out or if it is a mistake, and you can fix that. And another way is to do BOM validation, that you analyze your BOM based on the solution space to figure out if you have some over and under engineering. So that could be some continuous processes you're running by maintaining the product model.